Picking up on example 2, letter C, we have this. So we're going to use a lot of the tricks and tools from our toolkit here. And let's get it set up. So we're going to convert this to its log form. So log base 5. And can you see that we're going to take this and move it in front here? So this is going to be 2x minus 1 log 5 equals log. Now here, this is of base 10, remember, that's base 10. This is base 10 of 10. And then we're going to move this exponent that's here, x, to out in front. Now, you may recall, and I'll repeat this, that if you have log of base 10 to an exponent, this just becomes x. We've been saying that now for a number of times. So all of this, I'm going to use my eraser, goes away. So you now have this. Now, keep in mind that there is in a sense, this was a 1 here. So 1x. So now what we're going to do is fiddle with this side a little bit. And in a sense, we can put this in parentheses if we like. And we're going to expand this. So this is going to be 2x multiplying this by this. Theoretically, you can put a parenthesis around here as well. 2x times this, and this is log of 5 minus 1 log of 5 equals x. And then again, this is times 1 here. Now, what I'm going to do is I want to get all my x's on one side. So I'm going to take this negative 1 log of 5, and I don't need to put the 1 there anymore. I'm just going to move this to the other side, and it becomes a positive log of 5. And I'm going to take this 1x, move it to this side, where it becomes a negative 1. So again, I'm taking this, moving it to this side, and I'm going to take this, now let me write it out here, 2x log of 5, move this to the other side as negative x. So I'm moving this to the other side, just transposing it. Now I want to get my x's out of here, so I'm going to factor the x's out of here, and I get x, taking this x out and this x out, 2 log of 5, and then this becomes then a negative 1 here, equals log of 5. Wow, lots of algebra here. Now, I want to get this from this side. I want to isolate the x. So this is x times this. So I'll change colors here. I'm going to divide now both sides by this. 2 log of 5 minus 1. 2 log of 5 minus 1. So now these cancel out, and I get x equals this. Now you can put that in your calculator, item by item, and then be careful, all of this is going to be in parentheses when you divide. Or you could take the log of 5, get a value, multiply it by 2, then subtract it from 1, and then do this calculation. But I think it should work both ways. All right, now let's take a look at what the book has here. And we'll get a double dose in a sense. So we're converting each to log form. We're going to take this exponent and put it out in front here. And notice this is log base 10 of 10. So this side just becomes the x. We're putting this now out in front. We're putting this x out in front. And in a sense, this just becomes a 1, or cancels out, becomes a 1. There you go. Now, we're going to do this multiplication here. 2x times this, minus 1 times this. Now we're going to take this negative 1 log of 5, move it to the other side. Move this 1x to this side. That's where we get this. Now we're going to factor out the x's here and divide both sides by what's in parentheses. And we get this. Wow. Lots of stuff going on here. So as we take the decimal approximation, the log of 5 is this. The log of 5 is this. We're going to multiply it by 2 and then subtract 1. And rounded values, we get approximately this. Wow. Okay, now again, you can always replay this, going through it step by step, and you'll have your practice and certify. Okay, we're now going to solve equations with logarithms. The equation is in its log form. Now, to save a little time, I've set this up again. So, exponential form, we have our base to an exponent equals an answer. And then the logarithmic form is the log of a base of an answer equals the exponent. So in this form we have the exponential form. But to solve this, we're going to change it to its exponential form. So this is logarithmic form. We want to change to exponential form. So again, this is common log base 10. So what is our base here? Well, it's 10. What is our exponent? 3. And what is our answer? 5x. So this is going to be 1,000 equals 5x. Divide both sides by 5. X is 200. Something easy. So again, you need to be familiar with this. This is, I would, if I were going to my blue sheet, I would write this out on my blue sheet. Here, in this way, it's easy to hopefully easy to understand, and then converting it. Very useful. All right, let's go on. So they're converting it from its logarithmic form to its exponential form. They wrote it a little differently than I do, but that's fine. X is 200. Okay. All right, now let's take a look at this one. Now, as you look at this, hopefully you can see that this is in its expanded log form. So we can convert that to a more concise form, log of this, and then this would be times now. And keep in mind, this is our common log, base 10. So we're going to convert this to its exponential form. Now, this is going to be base 10 to our exponent, 1, and this is the answer. X minus 1, x minus 4. Okay, so what do we do here? Well, we need to FOIL this side. X squared minus 5x plus 4. We're now going to take our 10 from this side, move it to this side as a negative 10, and then we get x squared minus 5x minus 6 equals 0. So we're now going to factor this. X, 6 and a 1. Now you might have thought a 2 and a 3 would add up to 5, but it wouldn't give you this term after you FOILed it to check it. So this is going to be a negative and this is going to be a positive. And we're going to get x plus 1 equals 0, or x minus 6 equals 0. So here x is going to equal a negative 1, and here x is going to equal 6. Now, excellent work using all of the techniques that we've had. But if you take your negative 1 and put it up here, we have a negative 1 and a negative x. This gives you the log of a negative 2. Is that a valid answer? Well, no, the log of a negative is undefined. So, we reject this answer. And the only answer we have is this. Now, in your Hawks software certification, you've done all of this, and if you put in negative 1 and 6 as your answers, they're going to count it wrong. But on your blue sheet, if you have all of this work, I'm going to give you lots of partial credit. But hopefully you remember this, that you can't have the log of a negative number. So you really need to check your work here. All right, let's see what they have. Okay. Now they're putting it from its expanded form into its condensed form, and then they're converting it from logarithmic form into exponential form. Remember, this is base 10, and the exponent is 1. When they integrate, you get what we had. They're going to factor it. They get a 6 or a -1. Now, by putting the -1 in the original equation, you see that would be a log of a -2, which we said was undefined. Okay. All right, now this one's a little different, so write this down and we'll work it step by step. Now, notice this is the expanded form, and this is actually in log form. So we're going to put this into its condensed form, log of x, up here in the numerator. And this negative log goes down in the denominator here as x minus 1 equals the log of 3. Now, an interesting thing, since this is algebra, we can divide this side by a log and this side by a log, and the logs just cancel out, and we're left now with x over x minus 1 equals 3. Ah, well, that's a little bit easy. And again, this is 3 over 1 in a sense. So I don't know if you recall from algebra that you can actually, when you have a fraction equals a fraction, this is a proportion, we can actually cross multiply. So 1 times x will give us x, and then 3 times this will give us 3 times x minus 1. So we're allowed to do that. So this is x equals 3x minus 3. Distributing that. Want to keep our x's positive, so we subtract an x from both sides, get 2x equals 3 as we transpose that, and we divide both sides by 2, and we get x equals 3/2. And that looks like our answer. Okay, let's check it out. And again, we're showing the bookwork as well. They organize it. It's printed very nicely. Okay, now we're converting it to its condensed form. We're dividing both sides by log, and those cancel out, and we get this. So we can cross multiply, which is what they're doing here. And they're bringing the x to this side, subtracting it from 3x, get 2x, add 3x to both sides, and they get x equals 3/2. Okay, and 3/2 is a good answer, and that would be that one. Okay, now here they're using natural logs. So write this down and we'll work on it to get it done. Well, we're at another close to 20 minutes, so we'll do this one in part 3.